Just in case you decided you wanted to do the word problems now, so you had a little example to look at, here is one of them, and you'll notice I already circled the 117, but I will go through this with you anyway. So it says the ideal maximum heart rate for a 25-year-old person exercising to burn fat is 117 beats per minute. For every 5 years older than 25, the ideal rate is going to drop 3 beats per minute. So over 5, down 3 is what that's saying. Over 5, down 3. That has to do with slope right there in that. The 117 has to do with where they're counting from, because the bottom question says, write a linear equation to find the ideal maximum heart rate for anyone over 25 who's exercising to burn fat. So they're just going to start at 25, which is why I circled that 117. That is the starting point. So if I proceed on, here's what we're looking at. We want the ideal rate to equal the rate of change times however many years older than 25 we're going to look at, plus the starting value, which is the ideal rate for a 25-year-old. So here's what we've got. R is going to be our ideal heart rate. A is going to be the number of years that are older than 25. They must have thought age and rate for those letters. Then they did R, the ideal heart rate, is equal to negative 3/5. So down 3 over 5. So down 3 beats per minute for every 5 years over. And then I don't like the X in there, but it's times A, whatever age you're going to deal with that's over 25, plus 117. So there's your equation. Now, from there, they want us to graph it. Well, it's very hard to graph something that's going to start at 117. So sometimes what you're going to want to do is break your graph. You're going to notice right below the 112 there, they did a little chicka. It's a break. Just means we're not going to start at 0. We're going to start a little bit higher, but they're consistent in the way they count. So they're consistently going up 1 beat. So 112, 113, 114, 115, 116, 117, and then the number of years above 25. So they started at 117, and you'll notice they go down 3 over 5. So down 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. Down 3 over 5. So if we then want to find the maximum ideal heart rate for someone who's 55 years old, all right, so 55 is how much bigger than 25? That's one thing we have to figure out. Okay, that's 30 years older than 25. So we're going to be using A equal to 30. So there's my equation. I put in the 30. And then in my mind, I would be going 30 divided by 5, that's 6. So 6 times 3, that's 18. Negative 18 plus 117 gets me to 99. And so for a 55-year-old person, you want to get to 99 beats per minute. The next question then would be, the amount of money spent on Christmas gifts has increased by an average of 150,000 or 0.15 million every year. So up 0.15 per year. So my slope would be 0.15. And it's number of years after 1986. In 1986, they spent $3 million. So the starting value of this little thing is going to be that $3 million. So the one that's going to reflect that, slope of 0.15, up of $3 million, is letter B. And then once we've got that, we want to graph it. So we'd start, and notice they're going to count in millions of dollars, and we're going up 0.15 million. That's very hard to show, but I can tell you that graph B is constant. That doesn't have a positive slope. Graph C has a negative slope. And so this one, if I look down here at this one, this is up. So here it was sitting at maybe 2.75 is what this looks like for the starting amount. It's supposed to start at 3. Never mind. That's a problem right there. It doesn't even start at the right place. It's supposed to start at 3. and then it goes up and over. So even though the numbers are icky, they gave me ones that are going to match what we're working with. So that is going to be cooperative. And then if we want to find out how much is spent in 1999, okay, well, that is 13 years after 1986. So I'd put in 13 for my X, and I would be doing 0.15 times 13 plus the 3, and that's going to give it to me if I go in there. And if you type that all in, you should end up with 4.95. And that wraps up all of 4.3.